Welcome everybody to this talk about performance tuning. My name is Juan, and maybe as you all know, performance tuning is important. It's very nice for the developer experience. I think we all in this room hate waiting for the queries to load, and by the time they're done, you forgot what you were doing. But it's also good to keep the project scalable and to reduce costs. So why exactly we should care about performance tuning is a bit of a no-brainer. However, the objective that I had with this talk is a bit different. It is the moment that I started researching about performance best practices for DBT, I discovered something interesting, and that is there is very little out there on that specific topic. Now, most of the literature that you're going to find about performance tuning in SQL or databases comes from the time where databases are very expensive. So a lot of the concepts that you will find on the internet are outdated by now. Secondly, a lot of it is very engine specific. So you will find plenty of material on how to optimize performance for one particular data warehouse, one particular data lake, or whatever it is that you're using. But it's unusual to find something that is more global, that works everywhere. And even more specifically, something that is enabled by DBT. So my objective here is to share some tips with you about things that hopefully everybody here can do, regardless of which engine you're using, to make your projects more scalable and ultimately tune the performance, sometimes thanks to some features that are unique to DBT. Now, some of these tips may be obvious to some of you. I expect to see quite a lot of rock stars in here. But if there is 1, 2, or 3 tips that you take home that were surprising to you, or I'll probably notice which ones they were because you will take pictures of those slides. But yeah, if that's the case, I'll be very happy. Now, first things about me, as I mentioned, my name is Juan. I work for a consultancy company based in the Netherlands called Xebia. I am also the co-organizer and co-founder of the DBT meetup in the Netherlands. So if you're ever there and you want to speak, let me know. And with my company, we started very early believing in this concept of analytics engineering. I started with that actual title back in 2020, so it's been quite an amazing journey to see how it's evolving, how it's growing, and how you can just fill rooms with people that have it as a work title. Now, additionally, I've been also very lucky to have had clients where performance tuning had a very high return of investment. I think for most of you, for most companies, for more situations, optimizing the performance of SQL is just a secondary thing. So if you're one of those people that has been lucky to work in an environment like that, I guess you will know a lot of tips and tricks, and maybe you found yourself over-engineering performance. Now, let's talk about performance tuning. By that, in this talk, I'm going to refer to every single action one can do to make sure that your SQL queries run a bit faster. In this case, well, your DBT builds. One interesting thing is performance tuning generally follows the Pareto principle. Some of you might know it as the 80-20 rule, but practically speaking, that means just 1, 2, 3 actions account for most of the gain that you're going to get in performance. So the name of the game is never over-optimizing to death, but rather just good enough performance. Now, maybe some of you actually work in these companies where 1 extra second can mean a lot of money, or 1 extra second can mean saving a life, or something along those lines. So yeah, that's definitely a different situation. But for most of us, rather than working on optimizing, it should be a matter of adopting some of these principles on our day-to-day work. The first tip that I'm going to give you, and maybe raise your hands if you recognize this screen. Oh, this is solid 4th, I guess. So the first tip that I want to give you, even though this is a Snowflake feature, is don't trust me when it comes to performance tips. Trust your query plan, however it is that your product calls it. Every single product has a little window where they break down or they explain how the query is being processed. So I'm going to give you some tips, but as you know, it's been very tedious when I decided to give this talk to test this in every single warehouse that I have access to see if it also works. So please trust it, because even if it worked for me yesterday, in a month from now, it might be a bit different. Next thing that is important to mention is SQL is not a procedural language. It's kind of like taking a taxi. You decide where you're going, and you can give some minor indications of how to get there, but it's never you the one driving. You just give some instructions, and then whatever your engine is, people are going to work on getting you there in a more efficient manner. So these things are constantly changing. You know, you determine the what, but not the how. Now, the second tip might be painfully obvious to many of them, is what I call the don't put in your plate the things that you're not going to eat. So avoid selecting every column. Avoid the select stars. Just be very thoughtful about which are the columns that you want. Because even if you want every single column, it's still nicer to be very concrete about the names and having them there. But quite often, you only care about the fraction of the columns. The second one is filter whenever possible. Like, where statements are always your friends. Very rarely you want to analyze something over 7 years of data. And sure, these ones might seem obvious, but I thought I will bring it a little spin that hopefully is a bit new to some of you. That is, there is such a thing as the order of operations in SQL. As in, your SQL commands are actually executed in a set order, which is not the same as the linguistical one, which is the one that we type. But databases, yeah, just check SQL in different orders. So the earlier that you filter something out, the better. Of course, I was not going to memorize the order of operations, so I decided to bring it here with me. This is the order in which things get evaluated. And as you can see, some of these are very specific not ANSI SQL features that maybe are supported by your warehouse or not. But there are some interesting principles, as in things that you put in your where clause are always filtered out first than your having or your qualify, which is, if you have never heard of qualify, Google it, it's going to change your life. But this is only the order of operations for SQL specifically. Where DBT comes and makes things a bit different is we also have JinJa, which JinJa gets, except for one exception, which I thought it was a bit too crazy to even elaborate on that. But mostly JinJa gets evaluated even before this. So I've been trying to find amazing examples, and all of them that I could find were a bit hacky. So if you come up with one, please send it to me. I would love to see them. But know that whenever you do something in JinJa, like finding out today's date, generating random data, a lookup from a dictionary, a lookup from an array, iterating over an array, all of those things, you can offload them to your computer. And there is a small chance that your computer does it more efficiently than doing it in your database. Also, sometimes some of these features, like just sending those commands to your database, or your database doing them for every single row of your data, can become a bit less efficient. So just know that the earlier that you filter out something, the better. But you also have JinJa in the specific example of DBT. So make sure to use it, especially for looking up keys in dictionaries and stuff like that. The third tip that I have is partitions, clustering, and indexes. Now, to be fair, every single data warehouse and database out there has different techniques to optimize things. But I think, roughly speaking, these are the three most important ones. And to be really honest, many of the newest systems either do partitions automatically or don't even support indexes. So it's fine if you have never heard of this, if you have been working for 5 years or less. But the config blocks are your friend. So in DBT, you can always write something in the config blocks. Of course, the preferred materialization. You can also pass on comments. You can even write prehooks, all sorts of things. But I just wanted to highlight that things like partitions, index, and clustering are things that you can also define from the config block. And in some cases where you have very big tables, and specifically in some systems, it will pay off majorly if you include this. So it's not that it's a rule of thumb or a very important thing, but quite often you want, in the most important models, a config block. And if you really care about performance, check what are your options. Now, regarding those of you that don't know the difference between these three, first one is partitions. It's kind of like when you have a warehouse, and this is an analogy I heard yesterday, kind of when you have a warehouse and you put all of the things that you received today in this corner, all the things that you received yesterday in this other corner. It's essentially breaking the data into different files based on a certain field, which, to be honest, we were also talking yesterday, it's almost always a date, and I haven't heard any great alternative for dates when it comes to partitions. Now, clustering refers to the order in which the rows appear in this partition. So just changing the sort order makes it a bit even more efficient to find things. And finally, indexes, which, like I mentioned, most of the modern systems don't have. It's a copy of a column that is optimized for search. So once again, it's not that I'm advocating for doing all of these three, but just know that inside of your config block, there is plenty of great things that you can do. Not only just the materialize as table or something like that, but actually some of the performance tricks. The next step is about materializations. So if you know what exactly you're doing and what are the pros and cons of each materialization, that can also be a game changer. Now, DBT has some golden rules about this. And this is literally something that you find in their documentation, the key emoji and everything. And they are good rules, even though I think they're a bit reactive. So what DBT recommends is start everything as a view. If you start having trouble, turn it into a table. And if you're still having trouble, turn it into an incremental view, which is fine. But once again, this approach requires you to go to all of the trouble and fail before you correct for your mistakes. So here are some golden rules that I would like to add to this whole mix. The first one is views are particularly amazing when you're doing very little transformations. So quite often for your staging models, it's perfect, especially if you're very strict about only using staging for renaming, for casting, and maybe some very little things. Views should be more than fine for that. Ephemeral models are something that you should definitely look for, but they're a double-edged sword. So for those of you that don't know, ephemeral is just a CTE that lives in another file. They don't get materialized, so they don't create any clutter in your warehouse whenever you run them. But the downside is, since they're not being materialized, it becomes a bit harder to debug when one of the numbers is not giving you the right result. So I have had clients that are very strict about everything ephemeral if it's not consumption. But then you have to turn them into tables or something, or views, whenever there is a number that is wrong and you want to check all the way back. So use them definitely, but be careful with debugging. And finally, which is something that came very recently, if your data warehouse supports something like a materialized view, they tend to be very interesting. Now, they behave a bit differently depending on what's your warehouse. But essentially, materialized views often have a lot of the benefits of views, as in they're fresh, but they're also materialized, so they're efficient. If this is an option, especially for consumption, check it out. Give it a try. Now, the next step is also very DV-tonic, which is turn the CTEs in common into intermediate models. Now, personally, I think intermediate models are amazing. Whenever there is a transformation that is difficult, I love just throwing it in intermediate model because I know I can focus on that one thing. And this sometimes is like crazy joins or crazy transformations or user-defined functions or this crazy macro that sometimes goes wrong and I want to isolate. But a really compelling reason to use intermediate models is performance. Sometimes you're going to find yourself having exactly the same CTE in two different files. Exactly the same join, exactly the same cleaning up these fields. And if that's the case, well, have just one intermediate model like the image and have it work. I think this one is a bit obvious, but what a lot of people fail to realize in practice is these CTEs don't need to be identical. Sometimes close enough or similar tables is already a good reason to turn them into intermediates. So quite often, if 2, 3, 4 CTEs resemble each other in different files, you can just make it a bit bigger, a bit more bloated as an intermediate, and refer all of those models to that one. So experiment, just remember they don't need to be exactly the same CTE for this to be valuable in terms of performance. The next step is something that is also painfully obvious, and yet I'm 100% sure that it doesn't matter how much experience you have done this. And that is always remember to sample your data. Well, I said sample your data in depth, but in reality it should be sample your data everywhere that is not production. Quite often when you want to test if your logic is correct, if something is going right, if that's how the regular expression should work, you don't need to do it with 7 or 20 or 200 years of data. Sometimes with the last 3 days, 2 hours, 1 month, depending on your business, is good enough. So here are some tips on how to sample. The first one is you can specifically add an if statement using JinJa that is aware of your target's environment. You can also do this as an environmental variable, but quite often I see it like this. So what you do is you put this inside your where statement, and it says if the target name is dep, then only do this with the last 3 days of data. Now, adding this to your biggest tables or your biggest models, like especially those massive fact tables, can be great because maybe you're knowledgeable enough to not query this every time, but some of your end users might not know that that table is humongous. So just one person adding this statement, even though it might look like clutter, can save a lot preventively. So just remember you can refer to target names, and you can do great things in the where clauses with that. Second tip is remember that there is the select flag. So I think everybody, when we were learning DVT, we were guilty of DVT build. Let's wait 20 minutes, 2 hours for this to work. But of course, and this is a beginner tip, you can select your models, and with a plus at the beginning of the end, you can also build downward and upward dependencies. However, what is a bit more intermediate is DVT has some commands, like state new and state modified, that allows you to only target the things that you have created or modified. To be honest, when I heard of this, I almost always exclusively use state modified. Now, there is also defer, but that's didn't feel like talking 10 minutes about defer. So just adding this to your select statement can make it more lean. And this is something that you can just simply run without having to type the name of the model you care about. Now, the next step, it's a little bit of an anecdote, to be honest, and that is when people are doing DVT tests, quite often they forget a lot of the performance best practices. The first thing I will mention is singular test. Those are the ones that are actually SQL scripts that should not return any row. Those ones should always have a where clause, because those are queries, and surprisingly, quite often they tend to be the most expensive queries. And the sad part is sometimes, instead of fixing them, people start doing DBT run instead of DBT build because they think tests take too much. So always be very conscious about your where statements in those tests. Once again, only do it for the rows and the columns that you care about. And a really good tip is quite often you care about distinct values, not every single row. Let me give you an interesting example. Now, this is my interpretation of a test that I once saw. What it essentially does is it selects every single thing from a table where the users would register to an app. This app had a very interesting problem, and that is, even though they have like a scrolling thing for the country of origin of the person subscribing, the value saved in the database would be the name of the country in the language of the phone. So you had things like the Netherlands in every single language, just because, and they were correct values. It was not like user input, but it was in every language. So they did create some macros and some crazy things that would correct that, and that was very interesting. But they added this test just to be sure that their logic was working. And what it did is pick everything from the user registration table, which was humongous, do a left join with country codes, and just make sure that every single country that was clean is also somewhere in the table with the clean countries. So this is essentially an anti-join to make sure that every single value has been clean. But as maybe some of you can already see, this table has a lot of issues, and as users keep on growing, this becomes exponentially worse. Some tips that you could do here is one, you don't often care historically about the things that you have already cleaned, unless you do some major changes to the macro. You care about the new ones that you haven't validated just yet. So where clause in like only do this for the last 2 weeks or something like that would have been great. But even more importantly, you don't care about every single user registering. You care about the list of every distinct country, which, surprise, it was like, 200 rows or something like that? So you could have been doing a lookup in 200 rows instead of doing it with 200 million every single time. So just being mindful, thinking about distinct values instead of lines, and always adding where clauses to your test can make a massive difference. So let's do a little recap of some of the tips that I gave you. The first one is only put in your plate the things that you're going to eat. 2, the config blocks is your friend. Just add partitions, clustering, and indexing there. Experiment a lot with materializations. They work different from warehouse to warehouse, but being mindful about them can also save you a lot of time. Turn CTEs into intermediate models, even if they're not exactly the same, but just if they have similar joins or similar tables, it's already worth it to isolate them. Sample your data in development, even though I'm still going to make that mistake until the end of time, and so will you. Be very mindful of your test. Always add a where statement and just iterate over what you need to iterate instead of every single row. And finally, which was the first tip, is don't trust me, don't trust this presentation. Trust your query plan because, hey, who knows? Maybe in 5 years when we're watching this back, a lot of these tips will be updated. Now, to close this presentation, I have some sources, which, by the way, the reason I decided to do it is because it's so hard to find something that is DBT specific, or actually independent of which warehouse you use. So first one is a presentation from one of my colleagues. It's about CI, but he shares a lot of the tips that I shared and some more. Please check it out. Second one is from my friends in Budapest, Hi-Fi Labs. They actually talk about performance in DBT, but it's specific to Snowflake. And finally, if you have ever worked with databases and you care about performance, this is the Bible, like the timeless Bible. It might be a bit outdated, but back in 2017 when I first read this, it taught me almost everything I know about performance tuning in SQL. So it's not DBT specific, it's not cloud warehouse friendly, but a lot of these tips are timeless. Before I close and open up to questions, I also wanted to thank a lot of people because, hey, I didn't make up all of these tips. So thanks to some of my colleagues. I have here in the list Cor, Lasse, Guillermo, Boric, Donkey, Lucas, Ricardo, which some of them are here. But they were some of the people that either gave me direct input for this, or I actually learned just by looking at their repos. So shout out to them. And shout out to all of you. Thank you so much for your attention. The magic question is, do we have time for questions? And if so, how much? 4 minutes? Okay, I see one hand up. So. No, but I would repeat your question.
I was just going to say, have you ever had a situation where you were trying to make a model incremental or even add something like partitioning and or clustering, and either of those instances or configurations is what actually slowed the model down, and so you forwent those configs because it actually ran faster than if you had implemented those suggestions?
For sure. So the reason why it's so weird to find generic, always work tips is because there are exceptions. And indeed, actually somebody was telling me yesterday something about partitioning, something about incremental. So the quick answer there for those of you that didn't hear it is, if I have encountered cases where partitions and incremental models actually make the performance worse, the answer is yes, there are always exceptions, so that's why it's very important to be experimental here. Give it a try, but ultimately trust your query plan. Thank you. Yeah, we have some more.
So my question is on sampling your data, so specifically like the where clause that you did with the JinJa if dev. So is there something you could do project-wide, maybe in like project.yaml or something like that, where you can just say like for every model if then sample like limit 100 or something like that?
As far as I'm aware, no. But I also know that you don't want to do that in every single model that you have. So I think a good compromise is find the biggest fact tables, which is generally 5 to 20, depending on your business, and add it there. But I'm not aware of any way of doing it globally. Gentleman in the back had a
comment on his question, actually.
Oh,
Is it
okay. Yeah, sure.
You can create like a specific macro that you wrap the ref around in. And if you do like select star from ref where, like you can do like a dev filtered ref that would, where you can apply that logic to specific filters.
Thank you. Sounds good. And for
So I think you alluded to it a little bit, but I was curious what your thoughts are on kind of offloading some of the database-based calculations to more local machines. So say taking your data and taking it into a Python environment to do the more complex aggregations. Do you consider that a reasonable way to get performance, or do you think it's adding too much complexity to your system for the potential optimization you get out of doing that?
The answer is yes. No, I'm kidding. So that was actually one of the tips. It was originally 8 tips that there are some things that you can do in JinJa that are better. But if I have to be honest with all of you, I scrapped it almost last minute because every single example that I found that actually improves the performance felt either hacky or too complex, and I didn't feel like talking 10 minutes about that particular thing. So for sure, there are things that make your performance better if you offload them with JinJa, but it sometimes feels a bit too complex. So that's also like a call for everybody. if you find something like, oh, this is not a no-brainer, this is a no-brainer, always do this with JinJa, please let me know. But yes, so it works for performance, but it also comes at a cost. Okay. If that was all, I will still be around. Let's go have a drink later. And thank you all for your attention.